We are, by nature, explorers. The same curiosity that sends us to the stars at the speed of thought urges us to go there in reality. And whenever we make a great new leap, we elevate humanity, bring people and nations together, usher in new discoveries and new technologies. So remember to look up at the stars and not down at your feet.
Hey guys, really exciting evening. We're going to be doing a talk on stargazing for beginners. So great if you're just getting started, looking up in the night sky. I've got amazing clear skies in the northeast over the last day or so, and then we've got forecasted clear skies over the next 2 nights. So fantastic stargazing conditions. Lee, thank you so much for the stars. It's very kind of you. Elena's watching from London. Leslie's watching from Nottingham. Ronald's from New Jersey. Rhiannon's watching from Hertfordshire. Awesome stuff. Hey, Louise from New Forest. So, guys, listen, I am going to get started. If you have any questions, feel free to ask them at the end. It's going to be a fairly slow-paced talk, just giving you all tips on how to stargaze, getting into astronomy, that kind of thing. If you are watching in a group or a page and you are unable to follow or comment, all you have to do is follow my page, and within 15 minutes or so, or almost immediately, you should be able to comment. And the reason behind that is it's the only way to stop spammers. So now and again you get loads of people that decide to hop on and to try and get your credit card details. So guys, you don't want to be giving them away. But awesome, seeing loads of folks joining now. Michael's from Arizona, Paula from Essex, Bev from Cambridgeshire, Carol's watching from a cold Bridlington, Jeanette's watching from Whitstable, Kent Coast, Sonia's watching from Nottingham. Hey Johnny from Phoenix, Arizona. Awesome stuff, guys. Listen, I am going to get started. Thank you so much for joining. Very, very excited to be part of UK Astronomy's festival, Astronomy in April festival. So it's a month of talks from all different speakers. We've got some amazing speakers lined up for the month, and then you have people who are filling up the rest of the month. So myself will be helping out, doing some talks, and this is one of my favorite topics, isn't it? Of course it is, stargazing, and stargazing for beginners. So like I said, I've put this little talk together, and let's get started. So UK Astronomy, who are they? Well, UK Astronomy is a husband and wife team, and it's a charity down in Milton Keynes. And the idea is that husband and wife team and a growing team of volunteers help out to hold astronomical events. So although it is based in Milton Keynes, we're trying to expand our reach, and one of the reasons why I'm involved is to try and get UK astronomy going in the northern part of England, actually, well, certainly more of the UK. So we decided to Ross and I decided to put together this festival because we really wanted to do something online just to get everyone excited about stargazing again when the season restarts. So typically the stargazing season is September to March. That's when the deeper space stuff is done, because come March over throughout summer, the nights aren't as dark, but you can still see loads and loads and loads of amazing things. And I'm going to be talking about the kinds of things that you can see. And by the way, I'm noticing a lot of folks watching from all over the world. Anthony there watching from Frankfurt am Main in Germany. The great thing is, guys, it's one sky for all. So it doesn't matter where you are in the world, we all see the same sky. Unless you're in the southern hemisphere, in which case you do see another sky. So the different skies, so we see different skies, northern hemisphere and southern hemisphere, and this is all to do with the angle of Earth's rotation around the Milky Way. I'm not going to go into that, but it's pretty crazy stuff, and that's why we see different things in Australia, New Zealand, South America, South Africa, or Africa to us in the Northern Hemisphere. I want to talk about light pollution, guys, because this is about stargazing. Light pollution plays a big part when it comes to how many stars you can see. Now, of course, this makes sense because if you're in a light polluted city, so this is a light pollution map for the UK, and the regions where it's almost dark blue, this is almost zero light pollution. If you live in these red shaded areas, these are major cities. Obviously that's London, Birmingham, Manchester, Leeds, Newcastle, Northeast. These are the places where you're not going to be able to see as many stars, but it's okay, you can still see loads of things, guys. I don't want to literally say you're going to see anything, because you can still see lots of great stuff. But just to give you an idea of where I'm based, I'm actually based here, so within the International Dark Sky Park of Northumberland. So we have super dark skies, which means that we can see some really, really distant things. So let's just think about stargazing if you wanted to travel somewhere specifically to stargaze. Forgetting the fact for a second where you live, let's say that you decided you want to go on a stargazing break anywhere in the world, by the way. And what you can do is access a website called lightpollutionmap.info. That's lightpollutionmap.info. And it has a scale. It's called the Bortle Dark Sky Scale, and this is a ranking from 1 to 9, and the higher the number, the more light pollution that place has. So for example, if you're in a major city, this is how much of the Milky Way you can see. As you move further down the scale, so places where I'm based around a 2 or 3, then you can see a lot more of the Milky Way. Now, don't forget, guys, this talk isn't about dark skies. I do have another talk coming up about dark skies specifically, but I kind of want to give you an understanding of, just when you're getting started with stargazing, how much of an impact light pollution will have on what you may be able to see at your location. So if you live in a light polluted area and you go outside and you're thinking to yourself, hang on a second, Will said I could see the beehive cluster tonight, but I'm struggling. And you have to take into account your light pollution. But more than anything, the light pollution that will come from the skies, the moon is overpowering pretty much your normal street light. And this is something that a lot of people really understand. And I would say that the reason being is because most people live in a light polluted area. They don't see the contrast between a moonless night or a night where the moon is out. So this is a photograph that I took in Yosemite National Park in America a few years ago. And it was 40 minutes difference. It's actually the same photograph. So it's actually, the photograph goes from this side to this side. And all I've done is I've split it in half. One half, which is this part here, this is when the moon hadn't risen yet. So I knew there was going to be a moon coming out. It wasn't even a full moon, but the moon was rising. And as you can see with my camera settings, it was so obvious that you can see so many more stars compared to when the moon came out. Can you see the difference? So of course you're going to really struggle to see faint objects. And that's why if you decide you want to travel somewhere, and by the way, please understand this, I am talking about going out in the night sky, looking at the whole of the night sky, maybe challenge yourself and looking at super distant objects. Now, the reason why I'm saying this is because if you look over to the right, even when the moon is out, of course you can see lots of stars. And even when the moon is out, with binoculars or telescopes, you can still see most of the objects you want to look at. The main difference is they won't be as contrasty, they won't be as clear as they would if there was no moon. Okay, so if you are booked on a trip for stargazing, if you are going aurora chasing, don't be disheartened. You will still see stuff. It'll just be a little bit harder. But for things like planets and clusters, it probably isn't making that much of a difference. This is a photograph that I took 2 nights ago in Northumberland, so within the Dark Sky Park, and there was no moon. And as you can maybe see in the image, here we are, is some of the Milky Way that's coming out, the galactic plane of the Milky Way. And would I be able to take this photograph if the moon was out? It would be a lot more difficult. In fact, guys, I've just noticed there's Andromeda Galaxy. Hey, didn't realize I captured that in the image. So there's a galaxy there. I don't know if you can see that on the phone if you're looking at the phone. And actually, if you want, you can tilt your phone to the side and the image will look bigger. And over here, this is the double cluster. So these are really cool things that you can look out for in the night sky. So it's pretty cool. Another image, just a few nights ago, I was actually doing a space station pass over here in Northumberland, a live. You might have joined me for that live. It was super windy. And here we are. This is the winter sky setting. So I'm looking over to the west now. And there's the Pleiades, okay, the Seven Sisters. And there is Taurus the Bull, and there's Mars. Pretty cool, eh? Taurus the Bull, Aldebaran, Mars. And over here, of course, you can see Orion. There's Orion's belt, the Orion sword, the Orion Nebula, Betelgeuse. And over here is Sirius, the brightest star in the night sky. And all the way up here is Procyon, which is part of Canis Minor, the little dog. So there's loads more in the image, but you're probably thinking to yourself, for those just getting started, you know, how can I know that these stars are what they are? And it's no secret. The night sky of all the stars from our lifetime, so the time that we are here on Earth, is fixed. Okay, so the stars that you see, the patterns, the constellations, the asterisms, they're all fixed. So all you have to do is get to know the patterns, get to know where the constellations are, get to know the stars, and you yourself over time will build up this mental map of where everything is. And then you can even start to learn facts about them, how distant things are, like Betelgeuse or Betelgeuse is about 450 light years away. Sirius is about 8.1 light years away. So Sirius is a lot closer. Yeah, and then you've got obviously the open cluster of stars here. And you can learn all these facts about these stars in the sky. Here's something that I'm really excited about. And it's the galactic core. So when you want to go stargazing, this is one of the things I hear a lot, is that people take photographs of the Milky Way. Okay, we've all heard of the Milky Way. We live in a galaxy and it's called the Milky Way. And people take a photograph and they say, hey, I don't understand. Did I get my settings right? I can't see the Milky Way with my phone or my camera. I can't get it as good as other photographers. What's going on here? Guys, the galactic core is only visible in the UK certain days of the year. Certain days. Okay? So April, May is actually one of the best times to see it, April and May time. And it's an AM thing, so it's a 3 AM, 4 AM thing. Now, there's so many other things you've got to take into account, and maybe this is going a little bit too sort of into it, but when it comes to stargazing, there's so much you need to know. For example, if the sun is setting at, I don't know exactly what time, say it was 7:45 tonight. It's 7:45 p.m. tonight. Are you going to go out and stargaze at 8 o'clock? No, because the sun, even though it's set, needs to be below the horizon for you to be able to see the faintest stars. What will happen from the sun setting is maybe if there is a bright planet like Venus, or when Mars is very close to us, maybe you'll see the planets first, or even Jupiter, right? At about 20 past 8 or 40 minutes later, some of the brightest stars will be visible. So if it's winter time, then Sirius, no doubt, will already be there, and you'll already be able to see it. It takes approximately an hour and a half to up to 2 hours after sunset when we have what we call night. We have civilian twilight, astronomical twilight, nautical twilight, all these different twilight terms, which is in between nighttime and daytime. But on average, you'll have to wait about 1 hour and 45 minutes till the skies get really, really dark, on the condition that there is no moon in the sky. If the moon is in the sky, you're not going to have those really good dark conditions for you to be able to see things like the Milky Way. It makes sense, doesn't it? Of course it does. But it's things that you really have to take into account. I promise you, it's no good booking a trip to see the Milky Way if the moon is full. So, galactic core, I'm not going to go into it too much. Just be aware there are certain times of the year when the Milky Way is visible. Now, this image here is actually kind of a bit unfair, because this photograph wasn't taken in the UK. It was taken in Spain. So 2 years ago, I was in Spain, and I timed my trip to pretty much have the best time to see the Milky Way. In the UK, the further south you are, the more of the Milky Way you'll see. But just bearing in mind that you have to go at the right time of the year, and you've also got to go at the right moon phase of the month as well. So, with just the naked eye, we can enjoy things like the galactic core. We can see things like constellations and even the clusters of stars. So the most famous cluster is the Pleiades of the Seven Sisters. But this is another really cool cluster to look at. It's called the double cluster in Perseus. Very beautiful. I will point them out to you later, but if you're on a dark sky site, you can see them with the naked eye. If you're in a light polluted area, you can certainly see them with telescopes and binoculars. Absolutely no problem whatsoever. So if all of this seems a bit crazy, don't worry, it will all come together, because I'm going to bring up some software very quickly, and we're going to look at using software to find things. Just want to say a quick hello to Donald, and let's have a look. Sorry, guys. Just a few comments coming up, making sure there's no questions. So, guys, if you've got any questions, please ask the questions at the end. More than happy to answer them for you. And if you're struggling to ask any questions at all, it's because the only way you can comment is if you follow my page. So there are strict things in place to ensure that we're not being spammed. The world is full of spammers, and there's been times when it's just been crazy. So anyway, as a fail-safe thing, if you follow my page, then you should immediately be able to comment. Okay, guys, this is the secret to stargazing with a telescope. Okay, so if you have a telescope, or if you're going to try stargazing with a telescope, the next couple of things I'm going to show you using this technique will greatly increase your experience of stargazing with optical instruments. And it's a technique called averted vision. during the day, when you look at something and you look at it straight on, then what's happening is your eyes, this is like a little diagram of your eye is using the cones, because at the back of your eye there's these different, I don't know what you call them, sensors, to see different objects you're looking at. So the cones are great for color, okay, the cone at the back of your eyes. But the rods, which are off center, they are great for seeing in the dark. Okay, so the fainter stuff. So when you go outside and the first thing is when you want to stargaze, I'm sure you've all heard of this idea of having dark adapted vision. And that is the pupil of your eye, when it's in daytime, is nice and small to prevent too much light from damaging your eye. But when you are in a low light situation, your pupil will increase to help you catch in more light for you to be able to see more. And that on average takes about 20 minutes. So if you want to go out stargazing, have you ever noticed you first go out from a lighted room outside and all of a sudden you go, oh, there's not that many stars, and all of a sudden over time you start to see more. That's just your eyes adapted to darker vision. Now, when you use a telescope and you look at an object that's relatively faint, say a galaxy or a nebula, if you move your eyes slightly to the left or slightly to the right, all of a sudden you'll see that you can see objects about 20 to 40 times better than if you were to look straight at it. It's called your averted vision. If you haven't tried that yet, folks, for the ones who do have telescopes, give it a go. Look to your left and right, and all of a sudden that galaxy will just pop out and you'll see it a lot better. Very exciting stuff. So, as I said, I will be talking about some of the objects we can see in the night sky now and over the next couple of months. And the Leo triplet is one of the most, I would say, beautiful things to look at springtime in the night sky. And it's 3 galaxies. So we have one up here, one down here, one over here. The 3 galaxies you can have in one eyepiece. You see 3 galaxies at the same time. And I can't remember, I've just lost my memory all of a sudden. I think there's something like 30 million light years away, something like that. So these are very, very distant objects, and each containing billions of stars. But I will point them out to you where you can see them. And also, as we head towards the summer months, you can see things like planetary nebulas. So the Ring Nebula is a really cool one to look at. That's coming up, and I'll show you how to find that. Okay. Right, folks. So I am now going to bring up some software, which we've used a few times. And that software is called Stellarium. So if you use it for your PC or your desktop, then or your Mac, then it's free, I believe. If you want to use it for your mobile phone, you'll have to pay for it. But it's a great software to help you find things in the night sky. So I've just put it up, and hopefully you guys can see that okay. I'm just gonna let the stream catch up. I'm slight lag. I just want to make sure it has come up, and yep, I think it's come up. Okay, awesome. So this is I've put on this. This is in the UK. It actually isn't exactly my location, but it's okay. We're in the UK. And this is what the sky would look like. So obviously it's the sun is still up, still haven't set yet. But if you're looking here, we've got an N for north, so this is looking north. This is a projected skyline. This is not where I live. If you look to the west, so you can see the sun now is already over to the west as it heads towards setting. Now, generally we want to look south. So I'm just going to move this along here. And this is great. So you can put in on this software anytime, any day, and it'll give you a projection of what you would see. So I'm going to go forward in time, folks, by a few hours. So let's just 6 o'clock, 7 o'clock. Let's go to 11 o'clock tonight, because we're astronomers, and that is when we want to stargaze. In fact, I tell you what, let's just... this is interesting, isn't it? So remember I was saying that when the sun has set, you'll start to see the brighter things in the night sky. So this is 8 o'clock tonight. If you've got nice clear skies, look over to the south, and you should be able to see Sirius over to the south there. Brightest star, and you'll struggle to see anything else. That'll be Procyon, and maybe Betelgeuse there, and Mars is up there as well. But let's just forward in time. Let's take it to 10 o'clock instead. I'm going to zoom out a little bit, and we'll get rid of that information there. So here you are, folks. This is a projection of the skies at around 10 o'clock tonight here in the UK. And the first thing we'll notice, very obviously, is these stars here. So I'm just going to zoom in a little bit. So right now, you can still see Orion if you're in the UK. If you're in the States, you'll still be able to see it, no problem. You guys are, relative to us, lower in latitude, more towards the equator. So these stars will be further up in the sky for you. But as I was saying, recognizing the patterns, and I was speaking to Sonia. I think Sonia's watching right now, but I was talking about this talk tonight because here's the thing, folks. When we're talking about stargazing, one thing that I didn't notice. So when I was a child, one of my favorite things in the night sky was the Orion's belt. Okay, the 3 stars, and I used to always enjoy finding them and then just feeling comforted that they were there. But I remember it was one summer, I was looking up in the night sky and I was trying to find the belt and I couldn't find it. And I was really kind of, I don't know, I felt really uncomfortable. I was confused. Why can't I see the belt? And it wasn't until much later on that I realized that we actually see different stars depending on what month of the year it is. So generally different seasons, we split them into seasons. We have different stars in the night sky depending on what season it is. So winter time, we have the winter constellations, which was the Orion constellation is the main one, the most dominant constellation in the winter skies. And that now, because we are now in spring, although with -5 predicted on Monday, you wouldn't expect it to be the case. But we're now into spring, so Orion is now setting just shortly after sunset. And over time, it will get to a point where we'll have no chance of seeing it until autumn, end of autumn again. So that's the first thing you have to realize as a stargazer, is that there are different sets of constellations that will be in the night sky, and it depends on what season it is. Okay, so don't be looking for Orion in the middle of June. You're not going to see it. And don't be looking for Hercules in winter, because you're not going to see it. But as I was saying, we are looking at stargazing over the next few weeks from tonight. So we can still see Orion. I've zoomed out a bit there. So now there's south, there's west, looking southwesterly. There's the constellations. And you know what's really cool with the software? We can click on the lines, and that gives you the outline of the constellations, just, to help you learn where everything is. But another thing you can do is there's some really cool artwork. There we are. That gives you an idea of what the constellations, why they've got their name. So there's Orion, and he's got his little club. And then Betelgeuse is actually armpit. It means armpit. So it's the armpit of Orion, if you ever wondered what Betelgeuse or Betelgeuse is. I think Sirius is pretty cool constellation because it almost does look like a dog. If I just remove the artwork, guys. So have a look at this. So there's Sirius. In fact, let's just... Yeah, it's a little bit too... Okay, bring it back a bit. So can you see there's his head, his collar, his front legs, back legs, his little tail. I mean, Sirius does look like a little dog. And you might be saying to me, well, what are you talking about? Of course it does. That's why it's called Sirius. Well, no, that's why it's called Canis Major. Well, guys, this is my favorite constellation, and it's the little dog. So let's just zoom in there. Here we are, guys. See these two stars here? So Procyon is one of them. This is Canis Minor. These two stars, the little dog. So let's put the imaging. There you are. Looks nothing like a little dog. It's more like Canis Major. There's a little bone. But there you are anyway. So, interesting constellations to look at. We still have time to enjoy a bit of Orion and to see Sirius. Now, one of the things I want to talk about as well is a term called asterism. So you might have heard this term before. Constellations, you must have heard of it. And constellation is a pattern or a set of stars that make up one of the 88 constellations, in the night sky. And so, as I was saying, here's the artwork for them, and that's pretty cool. An asterism is a term for a pattern of stars that may be part of a constellation, or it may include other constellations. So an asterism over winter, and we call it the winter triangle. So Sirius, Betelgeuse, and Procyon, these three stars make up the winter triangle. Now we also have a spring triangle, which I'll talk about soon, and we also have summer triangle, and I'm sure there'll be an autumn one as well, but I haven't actually learned that one yet. I only started to learn these asterisms recently. So anyway, really cool to enjoy, but hey, we're heading towards spring, so let's talk about the spring night sky. It's now 11 o'clock, I've forwarded time. Again, it is still tonight, and all of a sudden, when you look south, south is really where we want to be looking at, okay? It's the point where the objects are at its highest point. It's called the meridian and prime meridian, and then it continues across the sky. So let me just show you this idea here. So there we are. In fact, if I forward time slightly, you can see how it all rises from the east and sets in the west. So the south is generally the best place to look because it reaches its highest point. But let's go back to 11 o'clock. Here we are. So what do we see here? We're looking to the south, and we're not looking at Orion anymore. And we see this interesting constellation here, which is called Leo. Leo the Lion. Let's bring in the little diagram. In fact, there's a little artwork there. So I want to talk a little bit about Leo and what's really cool to look at Leo. So the first thing is, what I love about Leo is you can see the sickle. There's back to front question mark, which makes his head. And loads of interesting things to look at when we look at this constellation here. The first thing I would suggest you do is, if you have binoculars or telescopes, is to look at this star here, Algebra. Algebra is really awesome to look at, folks, because it's a double star. Now, what does that mean? Well, I don't know if you knew this, but when you look up in the night sky and you see all these stars, did you know that more than half of the stars you see are actually binary star systems? So Ross talked about this last night, because we looked at the different planets of our solar system, and when we came to the planet Jupiter, he mentioned that people say that if Jupiter was bigger, there was a chance that Jupiter could also have been a star, and it's sometimes fairly or unfairly termed the failed star, because Jupiter is pretty much made up of the same stuff as stars. So it simply wasn't big enough for nuclear fusion to occur in the center. So actually, this idea of two stars in a solar system isn't that weird or abnormal. In fact, it's more normal for a star system to have more than one stars. So it's only when you get binoculars or telescopes that you look at a particular star that you then see the binary star, the other companion star. So here we are. When you look at it with our own eyes, you'll see one star. But when you zoom in with telescope binoculars, you see the two stars. Very, very beautiful to look at, folks. Algebra, one of the most, certainly one of the objects that I like to show guests when they come stargazing with us here at Twice Brewed. I was going to say something else then about algebra. Oh yeah. So here's the thing, folks. You're probably wondering to yourself, hang on a second. Why is it that with our eyes we can't see the two stars? Why is it that you got to wait until you use an instrument like a telescope? That's when you actually see the two stars. Well, it's because the function of telescopes is, yes, to magnify, but also to collect light. And it's all about resolution. So imagine, folks, if you're driving at night, you ever seen like a car very far away coming towards you at night? And when it's very far away, the headlights only appears as one light, doesn't it? When it's very far away. It's only when it starts to get a lot closer, that's when you see the two headlights. And this is the idea of resolution. So with most of the stars that you see in the night sky, we can only see the one star. But when you zoom in a bit more and get that resolution, then you start to see the two stars. But algebra is a particularly beautiful twin because of the brightness and the colors. And that's why we highlight this as one of the cool ones to look at. So you've heard of the Pleiades, you've heard of the Seven Sisters, and it is the most famous star cluster that's closest to us, and it's also naked eye visible. But there is another star cluster out there that is, if you're in a dark sky area, you can certainly see it. However, with binoculars or telescopes, it'll appear a lot brighter. So if you have joined me on a talk before with stargazing, you may have remembered that I always talk about these things called pointer stars. So one of the things that we do to learn things in the night sky is to use other stars that we know to help us find other things. So for example, I'm just going to go backwards in time a bit. Let's just quickly talk about Orion again. This is the best example I can show you. So I'm going to zoom in just a little bit more. So using Orion's belt, the 3 stars, we use it as pointer stars. Over to the left, we get Sirius. It points towards Sirius. And we go the other way, and it points towards Aldebaran. Okay, and then continue it, and we get to the Seven Sisters. So that's how you get started with naked eye astronomy, or even just with telescopes, is knowing the obvious constellation and using that to help you find things. Now, Leo, so we're going to move over to Leo now. Leo also can help us find things in the sky. And it's a great little thing. So here's Leo the lion, and there's his back. So what we can do is we can stroke the back forward, stroke it forward, and we get to Cancer, this constellation. But what's more interesting as well is this really cool cluster I've just mentioned, the Beehive cluster. So there we are. There is the Beehive cluster. Loads of stars that you can see, really beautiful with telescope binoculars. Guys, please give it a go if you haven't yet. Find the Beehive cluster, Messier 44. You find it by stroking forwards Leo the lion, and then you can't miss it. Really, really cool. Using Leo the lion again, you'll be able to... Let's get rid of these lines and the words. Okay, so this is the shape of it. Can you see this little triangle here, which makes up the back part of Leo? If you imagine a third triangle, so going around this direction, so making another triangle, over here is Messier 44, the Leo triplet. Remember the 3 galaxies that I showed you? Let's bring the lines in again, so you can help you find the triangle of Leo the lion. And then around this location is where the Leo triplet is. So the 3, remember these aren't naked eye visible, so you do need optical aid. And I'm going to type it in. You know what? It's not Messier 77. My brain isn't with it today. That's right. I'm not with it. So I'm gonna. You know what? I'm just gonna type in Leo triplet. There we are. Someone will have to remind me on here what it's called. 65, 60, 66. There we are. Oh, Okay, so it was a late night last night. I was stargazing till 4 in the morning. Oh, excuses, excuses. Anyway, listen. The triangle of Leo, and then here we are, M66. So let's just zoom in. Boom. And there we are, guys. Let's just get rid of those. There's the Leo triplet. So, give it a go, guys. The Leo triplet, M66, M65. And like I said, it's around this area here. We make a third triangle. And there it is. So that's really cool to enjoy over the next few weeks. Hey David, thank you so much. Just got your message there. Okay. Right. So let's talk about some of the other cool constellations that we can enjoy over the next few weeks. Now, as you can see from the diagram, we've got Leo the Lion, and I'm just going to bring in. Just double check the time. 11 o'clock. So this is tonight, 11 o'clock. Over here, and this is a really cool thing. So a lot of people see this star. Now, can you remember we were talking about this term, asterism? The most famous asterism in the night sky is the Plough, or people call it the Saucepan, the Pan, the Big Dipper. I can't even think of what other names people call it. But this is it. The 7 stars make up the Plough, or the Big Dipper. And the thing is that we always see the Plough. It's what we call circumpolar. It never sets. Doesn't matter what season it is, we always see the Plough. The only thing is the direction and angle of the Plough changes in different seasons. So you can actually, I mean, this is one of the great things, about astronomy. You can look at certain things in the night sky and you can go, oh, I know it's winter because I can see the winter triangle, or I can see, Orion. Well, looking at the Plough, depending on the orientation of it, you can work out the season, okay, at a certain time of the year. Now, I'm not going to go into the orientation of them, but all I want you to do is to recognize the Plough here in this diagram. And here it is, guys. The Plough is made up of Ursa Major, so the Great Bear. This is the constellation in its entirety. Remember, you can't see the lines in real life, but there's his head, there's his front paws, there's his back paws, and the Plough is part of its body and its tail. So that's all it is. The Plough is not Ursa Major, it's part of Ursa Major. And there we are, the full artwork for it. But the reason why I'm bringing the Plough up for you is because I want to talk about how it can help you find something. Well, it can help you find quite a few things, actually. But when you look at the Plough here, the tail of the Plough points towards Arcturus. So this is a really bright star. It's a huge red supergiant, and it's a great time of the year to see it. We don't always see it, but it's very prominent in the sky. And most people, when they see it, they do say, "Hey, what's that star?" And chances are it is Arcturus over to the east. But Arcturus is part of Bootes, the constellation here. It's the kite. Looks like a kite. But this, sorry, it's nicknamed the kite. But yeah, Arcturus is there. And here's another cool thing. Let me just get rid of the artwork again. So when we look at the Plough, it arcs. There's a little term we use, and it arcs to Arcturus. Okay, so you'll be able to see Arcturus from using the Plough to point at it, and then it strikes to Spica, which then continues down the line, and then we get another bright star here called Spica. So these are the really cool 3 bright stars, and the 3 bright stars, I just realized I just told you 2 of them. Arcturus is one of them. Spica in Virgo is another one. So Spica is now towards the south. And then finally, this star here is called Regulus. And one second, let's just get it. Regulus there. So Regulus is part of Leo the Lion, but it's actually these 3 stars that make up the spring triangle. So see if you can spot these guys over the next few weeks, or even tonight. Let me know you've seen it. But the 3 stars, so we've got Regulus in Leo, Spica in Virgo, Arcturus in Bootes, and we make up this spring triangle. This cool asterism. Remember, we were talking about asterisms that aren't just about being in a constellation. It can be made up of multiple constellations. Over here, now we're moving more to the east. So this is really what we're going to see over the next few weeks, these spring constellations. Over here is my absolute favorite constellation, and it's Hercules. Before we get to Hercules, here's another constellation called Corona Borealis, and it's like a crown, and the middle star is called Gem. So the middle star is called Gem, like a big gem. So you can look out for the Corona Borealis, like a smiley face in the sky. But if you look over, here it is Hercules, this really cool constellation. But I'm going to bring up the artwork just to give you an idea. So it's upside down, isn't he? But forget about that for the moment. All I want you guys to focus on is this. Let's forward the time a little bit. Let's take it to maybe the end of April or the middle of April. And here we are. So say the 25th of April, eh? So 25th, right, there's the moon out. So we'll continue. Okay. 30th of April, there we are. And now you'll notice that the constellations are moving on. So Leo is now past the south at this time. And you cannot see Orion at all. And now we're starting to see these cool constellations. So we've got Hercules higher up in the sky. Let's just forward time a little bit. And I want you guys to look at Hercules. This is my gem for the day. Loads of different things to look out in the night sky. One of the things is these things called clusters, which I've already showed you. Mentioned Pleiades, and we've talked about the Beehive cluster, which is an open cluster. But there's something called a closed cluster. So what we find in the night sky is these clusters of stars grouped up together. And an open cluster is where you've got approximately a few hundred to maybe 1,000 stars that are actually some of the youngest stars in the night sky. These, effectively what happens is that stars are formed in these areas of gas that we call nebulas. So the Orion Nebula is the most famous one. The Orion Nebula is loads of gas where new stars are being formed. These are stellar nurseries. Over time, they actually do become stars. And that's when we have our star clusters, our open clusters. So the Pleiades, or the Seven Sisters, is in fact a collection of some of the youngest stars out there, only around 100 million years old. But what happens is they drift apart over time, and they drift out from each other, and then they take up their place in the universe. What we've also found is closed clusters, or globular clusters. And this is the opposite. These stars in globular clusters are actually some of the oldest stars in the universe. So not around 100 million years old, but around 10, 11, even 12 billion, with a B, billion years old. And they're not clustered up together in a group of around 100 or so, or 1,000. They're clustered to upwards of 300,000, even 1 million stars. Some of the oldest stars in the universe. And Messier 13, which is the Great Globular Cluster of Hercules, is my favorite object in the night sky. So here we are. Here's Hercules. So where do we find it? You'll notice in Hercules, I'm just going to zoom in here. In this constellation, you've got these 4 stars. This makes up the asterism, the keystone in Hercules. So it looks like a keystone that, part of an arch of a building where you'd have the keystone in the middle. And what you'll find is in between these 2 stars here. So when you look at the keystone, you see the 4 A, B, C, D stars. Between C and D, depending on how you want to label them, here, or here, I'm going to zoom in, is Messier 13. So this should be it. In fact, well, it's in there. So this is Messier 13, guys. Let's zoom right in. That's how it looks. With a telescope. With a good telescope, guys, the globular cluster is incredible. Like, oh, it is, it's just beautiful. Absolutely beautiful. And you have to do it. You have to give it a go. You have to see it. It's just, I love it. Absolutely love it. And it's one of the most exciting times for me to be able to see Messier 13. So how do I find it? Like I said, you can use the keystone 1/3 of the way in, and you'll be able to spot it. Now, it's been said, if you're in a dark sky area, you'll be able to see it with the naked eye. Really, really tough. I think I've just about been able to see it. But how I find, one of the quickest ways I find it, and this is, I think I'm one of the only people to do it this way, is using the plow, guys. Remember, the plow is the 7 stars that make up the asterism. These 2 stars here, they point exactly at Messier 13. That's how I find it. That's how I find it. So M13, definitely an object for you to look at. Jackie, thank you so much for the stars. Very kind, very, very kind. Right, guys, that is it. I mean, there is so much more. I'm so excited to get into the summer skies because there's even more stuff for us to be excited about. But hopefully this has been really useful. I mean, I was saying, using Stellarium, you can really help you to learn the night skies, learn where constellations are, understand the pattern of how they rise and set, and how that changes over the months, but also the more difficult objects that are not naked eye visible, where once you get an idea and you know roughly where that thing is, then you can get your telescope out, then you can zoom in more, and then you can see more of the objects. So let's just bring back there we are. Yep, actually, it's not even a slide. So yeah, guys, listen, thank you so much for joining me for this talk on behalf of UK Astronomy's Astronomy in April festival. Loads and loads more talks, and lined up for the next month. And I'm going to be back doing some more talks as well, doing some more astro talks and everything else. But for the folks watching in UK Astronomy, I am the resident photographer, so my job is to help and support you guys. It has been very difficult because I get a mass of messages that come through all the time, and I do work through them. But if you do struggle with anything and no one in the group has helped you with answering questions, then always feel free to ask me directly, okay? It's my job to help you. Donald, thank you so much for the Facebook stars. I really appreciate it. But also for everybody else watching on my page, as a follower of my page, I am here for you as well. So feel free to message if you got any questions, photography questions, stargazing questions. I'm here to support you guys as a thank you for supporting my page. But guys, thank you so much for joining me today. And like I said, please join in for the rest of our astronomy talks. All the talks for UK Astronomy will be shared onto my page, my Wil Photography page. Okay, so don't worry, guys. If you are outside of the UK, you're not going to miss out. It will be shared onto my page. But guys, have an amazing weekend. I'm wishing you all really clear skies, and hope that you get to see loads of things and much more that I've talked about today. So take care, and I'll see you all really soon. Bye-bye.